Hello. In this screencast, I will demonstrate the clone detection functionality on MPS models. The clone detection is distributed as binary via MPS plugins, so please download the corresponding binary and unpack it in the plugins folder. I will show you now step by step how to use the clone detection functionality. I'm creating a new model and I will add the corresponding language to this model for allowing me to create configurations for the clone detection. Now I have a model in which I can create clones detection configurations. The configuration allows me to specify different parameters for the clones detection, and I will show some of these parameters in this screencast. You have parameters for characteristics of the clones, like minimal number of siblings that a clone should contain is 4, how big should a sibling be, maximum and minimum value, and so on. Next category of parameters specifies the scope for the clone detection. I will select global scope. Global scope means the clones will be searched for in all modules from the repository. And I don't want to detect clones of all modules, but only of modules with a certain name. And I can use regular expressions to specify this. After I have some initial configuration, I'm clicking on the node and start the clones detection. Usually the clone detection is very quick, and I have here the set of detected clones. If I want to obtain an overview over what happened, I can open a 3 map which shows me models containing clones. Now you can remark here that one of the big models are SwingX and Object Web and so on, which I'm not interested in. I want to detect clones in my code. And these models come here due to the fact that they are imported via stubs by one of my library solutions. I will refine the clone detection to ignore these modules. I will ignore directly at model level. Okay, here org jdesktop and something. After I'm defining the new scope, I can run the clones detection again. Hit run. I'm opening again the tree map, and now it's much cleaner. Black squares mean models where no clone was detected, and the red squares are models where clones were detected. So let's have a look what was here detected. I'm clicking and I'm diving in the model, and I'm filtering clones belong to this root. Double clicking on a clone, and I will look here by double clicking in the code to see what was cloned. And you might notice here that these nodes do not seem similar. But on the cloned node concept, we see that the detected clones are layout map entry nodes. And actually, we don't care about the layout map entry because they are there due to the diagrammatic notation. So I would like to ignore these concepts. I'm ignoring now the concepts. Layout map entry. Okay, I can also specify a reason why I'm ignoring this. After I've refined my search, I can run the search again. And now I have much less detected clones. Let's look now at some examples. So here I have an analysis results, tree table, and I have detected here a clone, and the clone is related to these nodes here. So basically, here I have 4 expressions, as actual parameters for my method call. Here I have four other expressions, and they are detected as clones. I would like to ignore them as well. And I'm making a regex about the name of the concept to be ignored. I'm rerunning the code, the clone detection, opening the tree map, and now things disappear from there. Let's have a look further. So here I have a cell renderer. I can filter clones from this root, and I see here several methods which take the same parameters. So I have parameter declarations which are considered to be, again, part of clones. Here I want to ignore rerunning the clone detection, and now I have even less clones. Let's have a look at this clone, for example, here. Okay, here there is some shape definition for the diagrammatic editor, and you see that this is genuinely cloned code because very similar code comes several times. This would be a genuinely detected clone. After you detect clones, you can define different post-processors. For example, I want to save the clones, and now clones are detected, and the detected clones are saved in that file. Pretty much this is it about the clone detection. In the repository, there is also an example project for running clone detection in headless mode. In the code applications, I have a demo project which with a Gradle based script which demonstrates how to run the clone detection functionality in a headless mode. I hope you enjoy this. Have fun looking at the clones in your projects.